Hi guys, my name is Mamadam.
My name is Azman,
My name is Elizabeth Islam.
My name is Aina Batisha.
My name is Karina Aisha.
and today we are going to talk about battery problems in cell phones.
Smartphones are essential for communication, work, and entertainment, but frequent recharging is a major hassle. As phones become more powerful, they drain energy faster, frustrating users who depend on them throughout the day for navigation, payment, and information. Even with faster charging, people often scramble for outlets or carry portable chargers. This highlights the need for longer-lasting batteries and energy-efficient design. As smartphones play a bigger role in our life, improving battery life is crucial to keep up with our demands.
Nuclear batteries use radioactive materials to generate energy, potentially powering smartphones for up to 50 years without recharging. This technology is based off of radioactive decay, which is still experimental but promises implications for device longevity and reduced battery waste. The advantages are extremely long lifespan, reducing the need for frequent charging and battery replacement, consistent energy source with minimal maintenance, and high density, generating significant power from a small amount of materials. The disadvantages are safety concerns due to radiation risk and potential contamination, strictly regulating challenges for development and deployment, and lastly, public skepticism about radioactive materials in devices.
Solar power is a well-known way of harvesting energy and has been used in many devices for years. By adding transparent solar panels to smartphones, users could capture enough energy from sunlight or indoor lighting. This would allow phones to charge without needing to be plugged in as often. These solar panels could be built into the screen or back of without phone charging its design much. Even in low light conditions, the panels could gather enough energy to extend battery life, making phones more convenient and sustainable by reducing the need of frequent charging and cutting down on electronic waste. However, there are some challenges. Transparent solar panels aren't as efficient as regular ones, especially in low light, so they may not capture enough energy. The technology could also make phones more expensive, which might turn off some buyers. Solar panels could add weight or bulk to the phone, which might affect the slim designs people like. Durability is another concern, as the panels would need to handle daily wear and tear. And lastly, some users may doubt how well solar-powered phones will work, especially in areas with less sunlight. Despite these challenges, with more development, solar-powered smartphones could become a practical and eco-friendly solution.
Kinetic energy charging captures energy from a user movement, similar to how some watches and fitness trackers generate power by using piezoelectric materials that create electricity under mechanical stress. This technology could be integrated into smartphones to harness energy from activities like walking, jogging, or shaking the device. While the energy generated is small, it could help maintain a basic charge, especially for active users. The advantages of kinetic energy charging is promotes sustainability by reducing the need for traditional charging. Secondly, enhance convenience by generating power from everyday movement. Thirdly, support longer battery life and align with health and fitness trend. Lastly, can act as an emergency power source when other options are unavailable. The disadvantages of kinetic energy charging is limited energy output might not fully charge or sustain a device. Secondly, less effective for sedentary users. Thirdly, engineering challenges in integrating materials into smartphones design. Fourthly, potentially higher manufacturing costs and impacts on aesthetic. Lastly, user might not fully utilize this feature if they are unaware of it.
we discussed some exciting technologies like solar panels that can capture energy from different light sources, kinetic energy harvesting that turns everyday movement into power, and even nuclear batteries that offer incredibly long lifespans. Each of these has its own strengths. For example, solar panels can provide continuous energy, and kinetic charging allows for self-powering through movement. However, challenges remain, especially when it comes to nuclear batteries, where safety and regulation are key concerns. But despite these hurdles, this technology collectively represents a shift toward more efficient and sustainable smartphone usage. As manufacturers continue to invest in this energy harvesting solution, we are moving closer to a future where our smartphone can keep up with our daily demands without the need for constant recharging. This could transform user experiences and contribute to a more sustainable future for mobile technology. Thank you for listening, and I hope you are excited as we are about these promising advancements.
Desmond, start.